Hello, we're going to make a small test of LevelSet segmentation with AMILab. So from when you load AMILab, if the path is well defined, the script path, then you have automatically a set of menu in the script menu where you can load some of the scripts that have a GUI. So you can, for example, create a 3D torus of a given size. You can set the two radii and the name of the resulting variable. You can automatically set the image size with a given margin based on the object size. So initially the size is 100 cube, but if I push on compute size, then the size is automatically computed. I create the torus and I show it in the image viewer window. This image has a estimated partial volume effect. It's an approximation of the partial volume effect. Then from this image we're going to segment it. It's very simple, but just as an example, we load the LevelSet script. Here we set the input image. So this image is taken from the list of images. Right now we have only one image is loaded. We can always update the variables. If ever there was another image, let's say I create image J equal to torus, so it's a second image the same, it would not appear as a list of image until I update the list. So then I would have J. Okay, so I need to load the input, then it pop-ups a specific viewer for the LevelSet segmentation. I can close the other one. I can also close the torus creation script. Now we need to have two windows in the same at the same time. So we can initialize the LevelSet either with manual created spheres or from another image. So this is a mode or manual or initial image. Let's take a manual mode. I would put the cursor with the middle button. So I use the middle button. On the Mac it would be Control the button. And I set the position, and I will add a sphere or 3 unit size. Usually it's millimeter. In this synthetic image, the voxels are voxel size is 111, so it will be 3 voxels. I add the sphere, and you can see that the sphere is drawn. The iso contour of the sphere is drawn here. Then this would be the initial contour, and from this initial contour I can compute the statistics inside this initial contour. I could have several spheres, so I could also have a sphere here. Let's put it a little bit inside and a little bit outside, it doesn't matter too much. Then we would have 2 spheres, and I can compute intensity statistics. So this the result of this statistic is shown in the output window. That here we don't see it very well, but I can also take it out. It says the mean intensity is 94, the standard deviation is 18, and we can see it here in the parameters. The evolution is based on 3 forces. They can be weighted manually with a coefficient. Here is a growing force, a balloon force, an advection force, and a smoothing force. Now the evolution tab, Evol tab, controls the main evolution parameters. So here it's set up to time step 0.5 and total evolution time 200, but there is a check for convergence every 20 iterations. So if the curve doesn't evolve enough, then between successive 20 iterations it will automatically stop to the evolution. So let's run this. There's a pre-processing. Now we see the evolution. The convergence test said it went to 0 and it stopped, so the convergence test decided to stop the evolution. So this is the result. Once we have the result, we can show it as a surface. We could also, if the evolution was not finished, we could also continue. We can rerun, change some of the parameters. There is a narrowband distance transform, and then we can save the results. So let's show the surface that results. It is with we see it in the 3D surface viewer of AMILab. There is the initial spheres and the resulting torus. So here we can put some transparency to the object. So in the view menu object, we can see object material menu, and for each object in the scene, so we can change parameters. Let's say now all object has the same parameter, and the yellow color is due to the light, which is yellow, but the light could be, let's say, light gray, and everything is gray. But we can set the initial two spheres with a diffuse parameter of blue, for example. Well, that's not the initial spheres. The resulting level set, and we can put some opacity here. So we would see the initial two spheres and the resulting level set. And we can go out of the application here. If I update the current variables, we see that there are a set of images now in memory, and we can see their sizes. Thank you.